He has attended the session from Amazon and learned everything about innovation. Ready to innovate? Okay, so we have a right session for you now. So the next session's here, just so that so this session is the business track, and it's about AI and ML in data science, engineering, and operational excellence. And the session in the other room is AI from an investment perspective. Just making sure in case people are in the wrong room. Okay. Today we are with us is Ravi. He's coming from San Francisco and has a lot of background in AI and ML. And he's the director of dev and operations at Coles and focuses on AI innovation. And his previous projects included AI IT ops innovations, getting operations, using AI in operations, and personalization and recommendation driven AI. So a lot of experience, relevant experience. So thank you, Ravi, for coming. Go ahead.
Yeah, thank you so much for the handoff. Ladies and gentlemen, good morning, warm welcome. I hope you guys are not sleeping or hungry still. So I like to have some feast with AI and ML. So I'm very excited to be here, being part of this Global Artificial Intelligence Conference, and I'd like to share my experiences on what is the impact of AI and machine learning in transforming this entire technology space. Essentially, the engagement of the customer and the customer experience in the space of retail as well, right? So do not focus too much on the slides and the content. I'd like to keep it more engaging, more interactive, and more fun, right? Rather a back to school session, right? I would not like to keep that as a back to school. So essentially, as being given an introduction, I'm predominantly focusing on AI and machine learning driven innovations and how do we achieve operational excellence, and to keep you guys interested, not to keep it as a presentation. I like to keep it as a more of a discussion, and would like to give you a walkthrough on a very interesting use cases or the case studies, which will definitely excite you on how we are transforming from one to another. So to start with, as a refresher, how the entire retail space is changing with the artificial intelligence and machine learning. If you look at it, right, you as a customer, when you are on a site to look for something or to buy something, essentially you use search as a criteria. Eventually, let's say you want to buy a shirt or a pant, right? The results from millions of inventory are being driven by relevancy and ranking complex algorithms. Out of millions of products, you've been thrown several thousands of products which matches to the criteria which you are trying to search, correct? It's awesome. It's a complex algorithms runs through towards achieving the relevancy and ranking, but that's not anymore. We consider that as a static experience, not an engaging experience, not a great customer experience. What does it mean from AI and machine learning? If you broadly classify the customers as a two categories, one, registered customer, where I have some information about your demographics, your personal information, your purchase history, right? Another set of category is anonymous user. They do not have any profile on the site. But eventually, if you even look at a registered user, they will never start their journey on a site by logging in directly and start doing their activities. Most probably, they will try to log in to do a checkout, right? So that means the platform do not have any understanding about who you are, what you are looking for, how do I keep you engaged, and how can I give you an outstanding experience. That's where the artificial intelligence and the machine learning are completely transforming the entire retail experience. The moment you are on a site, the platform, the complex machine learning models trained with complex data sets will start understanding you behind the screen, who you are, looking at your IP address, start deriving your geographical information. Hey, this customer is coming from this geographical location. Each and every of your interaction or a click on a site runs through artificial intelligence running beneath hundreds of machine learning models that are trained with the complex data sets to derive who you are, what you're looking for. You are a boy or girl, what age group you belongs to, what products are you looking for, what should be the better options I can recommend to you. I will start keep the experience will dynamic with every interaction which you do on a site, which will be processed through intelligent machine learning algorithms that you call models, which we train with the complex data sets and scenarios. Start deriving your results on a dynamic way. So essentially you're looking for a jeans pant or a t-shirt or a shirt. As I start understanding, hey, you're coming from this geographic location and you are a boy or you are a girl, you're looking for a branded Levi's jean, why not I recommend and try to understand what size are you looking for. Are you looking for an active, healthy life? Or you are looking for a business casual? Are you looking for a professional dress? Are you looking for an active wear? What kind of recommendations I can start providing you to constantly keep engaging and give a better customer experience? That's the way retail is completely transforming. Essentially, just imagine you are stepping into a store with a great companion who understands you really well, who can start recommending you, hey, this looks good to you, why not this? How about this, try this? So if you're stepping in, your entire purchase experience is outstanding and the fulfillment is great. But that kind of similar experience is being driven with AI and machine learning as we start understanding with every interaction you do on the site runs through artificial intelligence running hundreds, thousands of machine learning models which are well trained with the complex algorithms and data sets. That's the era we are in. So this is as a refresher, this I'm talking about one simple use case on how AI and machine learning are completely transforming and engaging you. The moment you are on a site, you have been guided, you have been recommended, you have been given an outstanding experience, right? So that's the era we are in. We are not in a state of, oh, I'll derive the results based on the relevancy and ranking now. We engage you, we understand you, we derive the results. So that's the era. So what it means now from operations standpoint. So define operations eventually to make it simplified way, site reliability engineering, which deals with availability, stability, performance, day-to-day operational issues. How do you analyze? How do you root cause? How do you restore? How do you resolve? So this entire landscape is now becoming even more complex. When we talk about how the entire technologies or organizations or retailers or any business is transforming, right? You see this three-dimensional strategies or approach that is going in across the globe. Number one, proprietary frameworks. Many of the solutions are built with the proprietary frameworks for the simplicity and easier maintenance, such as take the case of the Blue Martini or Oracle ATG, right, as an implementations, as a proprietary frameworks. Number two, monolithic codes. The entire application runs in a physical VM or a virtual VM as a single monolithic code base. So it's easy to maintain it, but the complexity comes in if I make a smaller change specific to a functionality, I'll end up deploying the whole monolithic code, right? And another thing, the third dimension I'm talking about is on-prem data centers, right? Self-hosted applications and on-prem data centers. So this is the third paradigm. That is the current to past, and now it is completely transforming from a proprietary frameworks to diversified open source technologies. We are not restricting ourselves to confine with what a provider is providing as a framework for us to be using. We have a diversified technology choices with open source technologies. That is a big shift currently. Number two, I'm talking about monolithic code to microservices. Now all the business is transforming into microservices for faster building, engineering, and deploying the code. Number three, on-prem data centers to cloudification, right? For a dynamic infrastructure. So I would not end up with any of the infrastructure issues where I could not scale dynamically on fly. So cloud is providing the capabilities of you can scale dynamically. So these three-dimensional transformation across the globe and across all the industry is bringing horrible challenges from operational excellence standpoint. Guess what? The traffic coming from various gateways, right? A web traffic comes from one channel, and a mobile traffic comes from another channel. It intersects to now, as your solution is completely transformed into microservices with the open source technologies hosted on a dynamic infrastructure cloud. So now the entire infrastructure is now bifurcated, such as your UI components will run probably in Nginx or in Node.js. That is dedicated infrastructure, right? You will have your HA proxies intersects the traffic for every single layer. And you have your stateless app stack, which carries the microservices code deployed in dedicated infrastructure. And if I drill it down further, the middleware is much more complicated, right? You have your in-memory caching frameworks such as Redis to whatnot, and you have complex databases, you take MySQL, Oracle, Postgres, Ingress, whatnot. And even further down, so you have to manage your secrets and even to manage the component interactions such as a vault and console, and an application configuration such as a Zookeeper, right? And even if I further drill it down for your message broker Kafkas, now this is your entire infrastructure turned out to be a massive footprint. Assume that how do I basically manage the operational stability, performance, and availability? If I keep 100 monitors in this room, launch 1,000 dashboards, keep 100 people, will it be even feasible to basically monitor and bring in the stability, performance, and availability to this complex infrastructure? No. But that's what the conventional operations are there for, right? So we deploy the set of resources, build an intelligent dashboards, launch the applications and dashboards monitoring, such as application performance monitoring tools, driven dashboards, your log analysis dashboards, your correlation dashboard, your traffic dashboards, whatnot you will launch in hundreds of the dashboards. Is it feasible now with this complexity where the technology footprint has transformed to the greater extent? Impossible. So what is the solution for it? That is where actually not only from engineering aspect, from operations aspect also, we brought in the AI and ML to transform the way we are doing the operations, right? So just wanted to get onto some of the use cases, start to keep the interest going in, right? To start with the smallest, simplest examples to more complex case studies. So I like to start with site sentiment analysis. Every site that runs on an infrastructure, not necessary to be a retail, right? The customer experience is predominantly very important for us to understand. Though your code runs through a complex release cycle testing, release process testing, software development lifecycle process, there is no guarantee that it gives zero friction to the customers. There will be always a lot of issues when an application deployed in production, when it is really being used by the end users. Of course, you guys know the reason. Can anyone tell? Even though you did an awesome certification validation process, you deploy the code in production, you will end up seeing issues from the customers, complaints from the customers. Because we do not test these applications against the real data. We do not test with the complex scenarios and the data and the profile that various customers holds for, right? The scenarios are different. So that's never be 100% coverage, which you can do through a release or SDLC cycle, right? So which is where the feedback platform, such as, many customers emotionally post their response and the feedback instantly before their emotions died off, right? To post their feedback and comments, their frictions, their issues that experienced on the site using a social networking and site sentiment or feedbacks tools such as Facebook, right? And there are even more advanced platforms such as Opinion Labs and all, which eventually captures all the customer feedbacks against the various sites. And retailers uses this data to understand, hey, how things are going on with the customers on the site. Are there any frictions and the issues? So these comments goes on hundreds every day. And you can understand customers what kind of language they use, how they abuse, how they put the words, how they try to write the comments. It's very complex to understand. But we cannot bypass this. We need to address this. Eventually, to understand hundreds of comments on daily basis, I might require to deploy several number of people to go through the each and every comment manually to understand is there is an issue or not. How do I articulate this issue? How do I build the scenario? So this is very resource intensive and very complex process to go through the customer feedback, which is completely AI and machine learning instrumentized, which has the simplest use. Because I'm talking about this is a very minor business use case, which AI and ML bring a lot of efficiency, where using the natural language processing, contextual analysis, and text summarizations, so the AI and ML reads, understands comments, correlates against the words they use, the URLs that they posted, because any customer who posts a comment, it will eventually take which URL he experienced the issue also, to understand and map it to what feature it belongs to. So hundreds of comments will transform into fewer number of meaningful problems and get alerted to the respective domains or SMEs for an immediate attention. So what we are achieving, the hundreds comments now drill it down to 3 or 4 meaning problems and being given to the attention of the right SMEs in a well-articulated fashion. So that's the simplest use case. But eventually there is beneath AI running through several hundreds machine learning algorithms to process this data, categorize this data, group, and alert the respective SMEs for immediate attention. So the friction and the issues that the customers are facing will be taken into action immediately. So that's the simplest use case I'm talking about, right? So moving on to another diversified, because I just want to make sure that the people from the different backgrounds, different interests are being, given the right use cases. So now we proudly say we migrated to cloud dynamic infrastructure. Now I don't have the scaling problem, infrastructure issues. I have the great compute available all the time. But the definition of cloud has to organically scale up as your traffic grows, organically scale down as the traffic dies. Is that happening with you guys? Have you seen any platform organically scaling up, organically scaling down against the traffic? So the dynamic cloud infrastructure being used to scale up in advance, use the reactive auto scaling capabilities that the cloud providers provides to us. What I mean by the reactive auto scaling policies, the auto scaling policies run through a threshold. Say set it, if my CPU exceeds 70%, or my traffic grows 30%, or my response times crosses the SLAs or near to the SLA, scale up. It's too reactive, because you're hitting that scenario and trying to react. Guess what? Any auto scaling capability provided by default by any cloud provider is never be as seamless. An instance to come up and start taking traffic, it takes 3 to 7 minutes. Anything can happen in between. You cannot rely on auto scaling policies to keep up your platform seamlessly to grow and handle the capacities. That is where actually I'm deep diving directly so I can take more questions. So this is I'm talking about the customer sentiment analysis, which I described before, how this entire AI and machine learning implementations drive this innovation. And I'm now talking about dynamic infrastructure scaling, which I typically call AI scalars or predictive auto scaling. Eventually, we are now taking this dynamics capacity calibration to predictability. my AI and machine learning models understands the traffic projections, the revenue projections, promotions, flash sales, also using the historical data, such as how would the similar day in the past look like, what's my system's consumption, what's my system's behavior, how should I position my capacity for my next hour, subsequent hours, subsequent days, scale up upfront, scale down accordingly. Post-business transactional hours. Every site has post-transactional hours. Eventually you call 10 Pacific or 12 Central. Eventually you'll see the traffic dies down on any of the site, right? But we just keep the site with, default capacity all the time. No one deals with scaling down and scaling up. This is a complex business. You would not be able to handle it. But the predictive autoscalers, which we have built with AI and machine learning, understand historical patterns of the site and systems behavior for a similar day, for a similar hour, for a similar campaign or a promotion or a flash sale. What would be the expected consumption of the systems and how should I position my capacity for 2 p.m. today or 3 p.m. today based on the projections data? Because business has all the projections such as how the traffic for the day, how the revenue by hour, by channel, all of these are predicted, right? But your infrastructure is a predictive base. So which is now we completely transformed, though our solution is completely hosted on cloud. So we achieve the AI-based predictive scaling where my AI scalars runs through all the projections data, understand the historical analysis of how the systems are consumed, how the traffic patterns, how the transactional patterns, which application stack I need to scale up. It is not a one thumb rule for your complex thousands of infrastructure, right? You won't scale 10% across all. You only need, I need to scale UI because many people will come and browse, they don't do transactions. The nature of the transactions and the traffic on the site will change every hour, every day, every week, every month. That's the trend, right? But the infrastructure is always static. Now we are bringing the dynamism in the infrastructure which pre-scales predictively and manages the platform seamlessly. So this is about one of the use case which is driven through AI and machine learning, right? Not just the customer journey, customer engagement of engineering innovations, but an operational excellence standpoint, how do we do that? So now which we will go into much more complex scenario, so which you guys deal, many of us deal on day-to-day basis, such as operations engineering, where availability, stability, performance, root cause analysis, resolutions and restoration. So which is much more complex, resource intensive, inefficient, conventional, traditional, whatnot. And even real estate, hundreds of monitors. NOC centers, people call as network operations center, where deploy several monitors and have a lot of people constantly monitor the dashboards to predict are there any issues, is everything smooth, right? So that's the current way the operations, conventional operations are, but now that is not going to work anymore with all this technology transformations and complexity on how the platforms are growing. So which is where actually the one what I talked about is the conventional operations, right? Basically the collecting, analyzing, and the reacting. So if you look at, there is a set of some activities that I put together, like what does it mean by collecting and what does it mean by analyzing and the acting. So how is it transforming with AI and machine learning? So this is typically, if you guys look at this, is AI Ops architecture. AI Ops stands for artificial intelligence for IT operations, right? Eventually your data is much more complex, heterogeneous, most importantly unprocessed. What typically I call a dangerous word called unstructured data. Unstructured data is of no use, complex to use, right? So what I mean by the unstructured and heterogeneous data is you have a lot of application performance tools, you have logs, you have various heterogeneous data such as your traffic, transactions, promotions, your incidents, day-to-day incidents that are, and your alerts. So all of this heterogeneous data get process real time for anomaly detection and outliers. Let's talk about your traffic, right, coming from a gateway such as Akamai or an API gateway FG for a mobile, right? So are there any outliers, anomalies? Do I have 5xx errors, which I need to react before it impacts the platform, causes an issue to the customer? Because currently conventional operational model is too reactive. We react when there is an impact. But with AI, you start predicting, hey, is there anything changing on the trend? Am I seeing any outliers? Am I seeing any anomalies which needs to be detected and reacted? Even the reaction to the anomalies and outliers as well automated, right? Driven by AI, which eventually streamed through your influx or a time series, which eventually always try to do comparison with your historical baselines to see that, hey, is this an outlier? Is it a trend? For a similar day, for a similar hour, for a similar system consumption, for a similar traffic, for a similar transactions, is it an outlier or an anomaly? Or is it a regular pattern? And constantly derive the baselines to understand, hey, now I see an outlier, an anomaly. What causing it? And drilling it down with AI-driven root cause analysis, keeping time. For example, you are seeing a UI response times are increased, right? So eventually, the AI will try to see how about services. Are the response times are good? Are the systems are healthy? Now, going further down from the stateless apps to the middleware, hey, is my database good? Is my catalog data from the Mongo is good, coming good? Are the in-memory caching frameworks are running well? How are the response times and health of all the systems? Where exactly is the problem which is trickling down and causing the issue and impacting the response times of the UI? So it does the root cause analysis, deep dives and pinpoints, hey, there is a response time increase from the database which causes the services response time increase, causing the UI to increase the response time. In a conventional way, if you look at every system will throw alert, right? Emotionally or to be defensive, we create a lot of alerts across. That means in this scenario, your database throws alerts, all the stateless abstracts will throw alerts, your UI will throw alerts. As an engineers, they need to look at every alert. That's too resource intensive and very inefficient. And there is no consistency, guys, right? If you're any organization, if there are 4 engineers, if you give an issue and ask them to analyze, each individual come up with a different hypothesis. There is no consistency, right? That is where we end up, hey, he is the good, or she is good. Let her to derive this root cause analysis, or he is best for doing it. But that's not a case we can live with it. I need a consistency. I don't care about who is doing what. I need a consistency when it comes to an analysis of root cause that can be derived through AI and the complex machine learning algorithms that we keep training with the complex data sets, right? So historical patterns will constantly store in the hive of the big data, and all the anomalies will constantly get rebaselined and stored in an influx or a time series databases, and they get transformed and take the course of action, such as what should be my root cause analysis. Once the root cause is identified, it can be automatically restored and resolved. Assume that a couple of instances are running with a high CPU. That can be automatically taken care of. I don't need any human intervention. Go ahead and recycle the instances by disabling it from the load balancer first. So I don't need a set of engineers to perform this operation, and this can be done seamlessly, and it's very fast and consistent, right? So this is the journey of AI Ops, which we actually like implementing in multiple phases. We have succeeded, and we are keep enhancing this entire AI Ops infrastructure and whole platform to take the operations to the next level. So I see the time check, so I like to put a halt and take your questions. As I said, not a back to school session. I'd like to keep it as more engaging and interactive. Yes, sir.
What is A in ANN?
So to me, honestly, as we are all technologists, I would consider A is not artificial. A is algorithmic. What is artificial? It is an algorithm, correct? It is algorithmic IT operations.
No, ANN, neural nets, I assume.
Yeah, so this is a machine, this is your natural language processing. NLP.
NLP, so stands for what?
So basically, ANN is a technology platform for natural language process. So which for the contextual analysis and text summarizations, understanding if an alert comes, it reads the alert, it understands the context summary, and it also does the text summarization. When it creates an incident, the NLP eventually writes this incident summary and throws it. Any more questions? Yes.
So I find it interesting how this is like pointing AI at the problem of like alerts for the purpose of consistently queuing work for different types of issues. Is what I gathered. Before unleashing AI on this problem, was it considered to, instead of having like a text alert, have like status codes and queue work based on status codes, like or I don't know if you have traditional more traditional metrics as addition to this, or what were your thoughts on that?
So that's a good thing, right? So the alerts are for the different reasons. Though you have your monitoring, intelligent monitoring established against various status codes, which we talk about, like a 5xx system errors or 4xx end user errors. So that you will always have an alerts. You set a threshold. The threshold is you will not keep it as a too sensitive, because it's you end up always doing the false analysis, right? It's not an issue. You always actively, aggressively have to do it, right? So, which I'm talking about, it could be an exception, a new exception, right? It is an alert. Or a change of a existing exception trend exponentially is increased, that could be an alert. Even this HTTP response codes for the client side or server side is also an alert. Right? Any anomaly is an alert. Right? It's just not only on the status code standpoint, but anything that you detect as is an alert. From your timeout standpoint, your connections, how many connections are being opened, right? You will have a thresholds for everything to say, hey, am I seeing hotspots? How many threads are being opened? How many connections are being established? What is the max allowed? What should be my threshold for it? How my response times? Is there an increase in response times? How is my heap? Whatnot, all of this we consider as an alerts. But end of the day, look what? The conventional operations is alert fatigue. We are emotionally, or to be defensive, we create a lot of alerts. That creates so much of overhead for engineers and developers to start looking at every individual. You cannot bypass, you cannot ignore. Otherwise, you might be missing something, because there is no correlation. Every system throws an alert. But who understands this? That is where actually the AI does most of your work. When there is an alert, it starts probing the entire system and scans the whole system to detect what's going on. Any more? Okay?
Okay.
Thank you so much.
Thank you, Ravi. Wonderful session.